All right. Welcome, everyone, here in person in Cleveland and joining virtually. I am Josh Mandel. I'm the chief architect for the Smart Health IT project and for Microsoft Healthcare. And I am very excited to get to talk with you today about the Smart Health IT project overall and a real focus on the Smart App launch. And we are going to have time for questions at the end, so whether you're virtual or in the room, if you've got a topic that you want to discuss that I don't bring up, please save questions. We'll keep at least the last 10 minutes for them. But for folks in the room, during the course of the presentation, if I say something confusing or if you miss something or if you need a little bit more detail, don't hesitate to just raise your hand and I'll repeat your question and take it in line. For me, it's one of the exciting things about being here in person is that we can have some more dynamic interactions where that's possible. That said, if you want to link to these slides, the first few slides will have the web link at the top. So that's bit.ly/smart-fire-tech. And there's a few different slide decks at that URL, including this one. And if you want to reach me on Twitter, at Josh C. Mandel. The other housekeeping note is you see this little FHIR DevDays tag at the bottom of the presentation title slide. I have this little badge sprinkled throughout the presentation on topics that are also being addressed by other sessions here at DevDays. So you can think about these as cross-references or forward pointers, or in a couple cases, backwards pointers to things that happened yesterday, but which you can access online if you want to get more detail or follow up on any of those topics. And I'll try to highlight them as we go, but otherwise they're there for your reference. So let me say just a couple of things about the Smart Health IT project. When I first graduated from medical school and joined the research faculty at Boston Children's Hospital and Harvard Medical School, it was for this project that had just been funded to work on health data APIs and generally trying to make it easier to connect tools and systems to the health records that stored all kinds of patient-level information. And the insight here from the beginning was, wouldn't it be really useful if we could help the people who wanted to solve problems to solve those problems more directly? And we'll get into the details here, but we wanted to provide a common platform for apps. And I'm not going to talk too much about the history, except to say that the big arc here would be that I started working on this problem domain in the research world and got more and more attracted to the question of what does it take to put this stuff in real-world production? What are the regulatory aspects of the problem? What are the production vendor systems, EHR production management aspects of this problem? How do we take this idea and make it real? And I hope I'll convince you over the course of the next 30 minutes or so that this is something we've done in the US. It's also happening internationally. And having kind of a research base for some of this work has been a really important ingredient, I think, in this success. But let me dig in and talk more about the stuff that's real today and relevant for app developers who want to connect into the health data ecosystem. And one framing for this is to look from a clinical perspective. I'll also talk from a patient perspective. But from the clinical perspective, one way to think about this problem statement would be something that we heard from a report that we did a few years back in 2017, that was run by KLAS, basically interviewing clinicians at different health systems, interviewing health IT management staff about their challenges integrating the different tools they had. And this is a good representative quote, which is, we had this wonderful population health tool, but we couldn't get the EHR to interface with it, so we had to enter all the information in by hand, and eventually we just had to give up because we couldn't keep up with that process. And that was true in 2017. There's a lot of ways in which it's less true today, but also a lot of ways in which it's still true today. And I think when we're successful, we chip away at this problem. We reduce it year over year to the point where the basics of this integration become table stakes, something that every EHR system can support out of the box. So what does that mean? What does it mean to have an app that hooks up to an EHR? This has been kind of the core focus of the Smart Health IT project. And we started this before FHIR was a thing, but as the FHIR standard started to emerge, I got really interested in how do I work with this community that's already solving so many of these problems. There was just a lot of shared alignment trying to solve some of the same things. So ultimately what we're trying to do is connect healthcare apps, like you see on the left-hand side of the screen here, to clinical data systems, like you see on the right-hand side of the screen. And apps could be so varied that I won't even try to paint the space directly, but I can give you a few examples. So in my early work at Boston Children's Hospital, there was strong interest in apps that could help manage blood pressure for kids. And managing blood pressure for kids is a little different than for adults. And the main difference for a clinician is that for adults, you just keep a couple numbers in your head. You can say if the systolic blood pressure is higher than 140 or 130 as the guidelines have progressed, that's high blood pressure, hypertension. I know I'm going to have the conversation with the patient about that. I'm going to start some, maybe taking measurements, maybe start some medication, lifestyle changes. For kids, it's different. The normal blood pressure for kids changes as kids get older. And to calculate the normal blood pressure requires that you know how old the child is this a boy or a girl? How tall are they? Because the blood pressure norms increase with height. It gets complicated enough that clinicians can't do it in their head. So that was one of the early motivating examples, was just, can we take this blood pressure data that lives in the EHR and the height data that lives in the EHR and just present it to clinicians in a way that makes sense so they can easily see, okay, given all the background information, is the blood pressure high or not? That's just one example of a healthcare app. But really, it's anything that an app developer or a clinician thinks would be a useful thing to plug into the health data system. And similarly for patient-facing apps. You know, what do I need as a tool to make sense of my own information? Look at my treatment options, evaluate where I could get a second opinion. How can I make sense of all this data? And then on the right-hand side of the screen, we have highly varied clinical data systems. The most common story in the US is thinking about integrating with an EHR, so these kind of enterprise software packages that individual hospitals, health systems, clinician practices deploy. And in the US, at least, we have a whole set of requirements that come from regulations around what those EHRs need to do. And we'll talk about those in a little more detail. But we also have patient portals, we have research data warehouses, many different kinds of data systems that can house clinical information at the individual level. And ideally, what we want to do with SMART is provide this kind of bridge or app platform so that these apps can plug into the varied clinical data systems by describing what are the key jobs here. So one is UX integration. How do we take a third-party app, which has its own buttons and widgets and titles and text and its own UX, how do we take that and put it into a clinical data system or put it into a patient portal? Because eliminating that friction, particularly for clinicians, of switching between apps is a really important part of the puzzle of deployment at scale. Another piece is authorization. So how do you make sure apps can get access to the data they need without accessing the data that they're not supposed to have? Part of that puzzle is single sign-on. So how do you make sure that the app knows who the end user is? And there's some cases where that's important and some cases where it's not. But when you need it, you need it. And so how do you make sure that a user can sign into that app without having to create a separate account for every app they want to work with? This is important for clinician-facing apps where it would be unmanageable to maintain a different account for every app that you want to integrate with your EHR. Signing in and signing out would be just a huge burden. But it's also important for patient-facing use cases where individuals might not want to share that much information with every app they choose to use. And then finally, once you get past the UX integration and the authorization and the other security pieces like single sign-on, you need access to clinical data. You need access to the structured and unstructured records that these apps are ultimately going to use to make their recommendations and surface their visualizations and so forth. And so that's the basic package that we try to put together in SMART. It's really a collection of open standards that we package together in a way to help solve this problem. So from a user perspective, like, what is the point here? You could think about it as substitutability, which is kind of a fancy word. SMART is actually an acronym that stands for Substitutable Medical Applications and Reusable Technologies. This is important when you're grant writing. You gotta have a pithy acronym, and you gotta explain how what you're building fits into the rest of the ecosystem. So for users, it really means that you can switch out one app and swap in a different one if you find a better tool for the job. So blood pressure management being an example, if a better blood pressure management tool comes around, or a better clinical scheduling application, or a better electronic prescribing application, you should be able to pick the one that fits your workflow and your needs the best without having to change up all the rest of your infrastructure. And for software developer, what it means is that you can target one set of API definitions. You can integrate with EHR vendor A and EHR vendor B using the same code base and without having to rewrite your app. And I will put an asterisk here, because in the real world, nothing works out of the box, cross-platform, perfectly well. I mean, this is just sort of the state of reality. I think it always has been, and it likely always will. But providing this common set of building blocks really chips away at the integration cost. And so yes, maybe you are still managing or maintaining some custom code for integrating with different systems, but it's getting dramatically smaller year over year, and it's really just focused on the edges as the core specification improves. And this is the other key message here, which is this is a product of the community. We focus on the problems that are most pressing, and each year we try to make these specs better, more comprehensive, improve the documentation, better examples, better tutorials, and on down the line. And in that vision, one of the capabilities that a modern EHR has is to be a platform, to deal with the stuff that you wouldn't naturally want every app to have to do. So it would be crazy if every app had to deal with user management and patient population management. It would be crazy if core workflow orchestration needed to be rebuilt as part of every application in the suite of clinical tools that you used. It would be crazy if every app had to figure out its own story for how to persist clinical data over the long term, right? And so the EHR has already solved these problems. It's really good at this, and it's a tool that's trusted by a clinical organization to manage those problems. And we don't want to duplicate that work. So the idea here is applications can plug in on top of that platform and take advantage of those core services and provide more value, provide additional tools without having to rebuild that wheel. So that's the basic value proposition. And let me just say a couple of things about adoption at this point. I'll focus on the US because it's the domain I know best. But the smart specifications have been designed as what we call universal realm, which is an HL7 term for specs that are not intended to be used in just one region. They're intended to be usable anywhere. And that really was the vision for the smart app launch specification. Doesn't matter what country you're in, doesn't matter what your favorite terminology or coding system might be. We should have a consistent way to plug apps into these EHR systems. And then on top of that, what we see is national profiles being built to deal with some of the specifics around data, vocabularies, terminologies, and so on. So in the US, we have a set of FHIR profiles called US Core that says things like, when you're managing medications, you got to use RX norm codes. Or when you're managing lab results, you got to use LOINC codes. Those are the kinds of things that the FHIR US Core implementation guide says. But we have a pretty generic way to talk about plugging apps in and doing authorization. And there's very exciting work that's underway right now to take those same kinds of things we've built in US Core and internationalize them. So there's a project called IPA, or International Patient Access. And you'll see I've added the little FHIR DevDays badge on both of these because you can go to sessions on both of these topics if you want to dig in and learn more about what's happening both in the US Core and in the International Patient Access spec. But I promised I would be a little bit US specific here. And so this is what we call the certification timeline. As of 2020, the Office of the National Coordinator for Health IT in the US has published a set of regulations that require every certified EHR product to actually support some of these APIs out of the box, including FHIR US Core, including Smart App Launch. And I'm not going to go into all the minutia of these regulations, but just to highlight a couple of dates. By the end of 2022, every one of these certified products needs to have built support for these APIs and needs to have it available for customers to deploy. So the big vendors have mostly done this already. I'll show you sort of where the source of truth lives for that information at the end of the presentation if you want to do a deeper dive. But that's really happening today, and we expect that it's going to ramp up very steeply by the end of this year. And then there's also this sort of missing piece. If you think about what we cover, if you think about the capabilities and data access that we provide with a core data set, it's not everything. It's right there in the name. The US core data set is a set of core data. It's not the whole clinical record. But the whole clinical record is often important. So how do you bridge that gap? And right now, the regulatory plan is a concept called EHI export, or Electronic Health Information Export. I'll talk about that in a little bit, but I just want to plant that term in your mind. And by the end of 2023, every EHR has to have some story for doing that full export. It doesn't have to be standardized, but it has to be available. So that's a little bit about adoption. These are real apps deployed in production at scale today in the US, and at least available for individuals to access in the UK and in Canada, and we see this collection growing. Let me dig in now and talk a little bit more about some of the underlying platform capabilities, and I'm going to start with authorization. So if you're familiar with OAuth, this is going to feel like old hat, because what we've done is just to take an OAuth flow and fill in a couple of the blanks that OAuth leaves as options in the core specs from the Internet Engineering Task Force. But the basic idea here is there's this dance between an app on the left and an EHR on the right in order to get the app authorized to access data. And I think about this as basically 3 steps. The first one is an authorization request, where the app says, hey, I'm trying to connect to some data. Here's what I need. And there's a decision that's made. Typically, that decision is some kind of shared responsibility between an end user, which could be a patient or a clinician, as well as the organization that maintains the data. So for patient-facing apps, it's usually left entirely up to the patient. The organization will surface a screen that says, like, hey, it seems that you're trying to connect this app to your data. Do you want to proceed? Yes or no? That's the most typical user experience for patients. For clinician-facing apps, it's usually more automated because you wouldn't want a clinician to have to like approve the app that they run 12 times a day. And so typically it falls more back to organizational policies and rules. But over the wire, there's an authorization request, and then a response that comes back, yes, it's been approved, or no, it's not been approved. And then I'll put a little asterisk there. We'll talk about scopes in a moment. But scopes are a way to request specifically what data you need and to communicate specifically what data you've been given access to. And those aren't always the same. So if you've been approved, if you've been granted access, then you can get, here in step 2, an access token. And that is kind of the technical artifact that you're going to use to make data API calls. Every time you make an API call, you're going to pass along an access token that's going to demonstrate, yes, I have permission to make this call. And then finally, in the third step, you make the API calls. So you make a FHIR query that says, I'm looking for all hemoglobin A1C observations from this patient during a certain date range, would be an example of a kind of query you could make once you get that access token. And then your app can take that data and do whatever it needs to do. So that's the basic OAuth flow. And you'll see that I've labeled this slide as the smart standalone launch, because we actually have 2 flavors of this flow. Standalone launch means that you're starting from the app. So for example, on my phone, I have the Common Health app that allows me to connect to my healthcare provider. If you've got an iPhone, you might have access to the built-in Apple Health app, which has the health records feature that you can connect to your provider. And those apps use exactly this flow here. It's the smart app launch standalone flow. You start from the app, you tell the app which EHR you want it to connect to, and you connect. The other variation here is what we call the EHR launch. And if you look closely, you'll see that I've just added a step 0 here. The EHR launch is very similar, but it starts one step earlier in a workflow. This is for a clinician that's inside of their EHR, and let's say they want to run that blood pressure management app that I mentioned earlier. They want to see how a kid's blood pressures are doing over time. So from inside of the EHR, they might click a button or switch to a certain tab of the EHR that has been configured to launch a particular app, and then the EHR opens an inline frame onto the app's launch URL. That kicks off the process, and then the rest proceeds exactly as I described earlier. So the EHR flow is really just designed for the case where an end user is starting from inside of the EHR rather than starting from inside of the app. All right, let me just ask for people in the room before I go on, any questions so far, anything I've said that's like either confusing or didn't make sense? All right, let me push ahead then. Let me tell you a little bit more about this scope language. I mentioned that when an app requests authorization, it can say more specifically what data it wants. And today, scopes look something like what you see on the screen here. A scope could be patient/immunization.read. And that's a way of saying, I want to be able to read all immunization resources that pertain to the current patient, the patient that's in context. And the idea here is that for some apps, really for a lot of apps, when you launch them, you're launching them on a particular patient record. So as an individual patient, when I'm connecting an app to my own record, I'm the patient in context. As a clinician, if I have a patient's chart open and I want to see their blood pressures, whatever chart is open, that's the patient in context. It's not universal. Some apps don't have a single patient in context. We can talk about apps that have user-level context that might need to make queries across patients. Like maybe I am doing a population view, and I want to see how my whole panel of patients is doing on some measure. But most apps these days tend to have a patient in context, and so this is how you can request access to just the immunization resources for that patient, and so on for different FHIR resources. I will put a forward pointer to the Smart v2 talk that we're doing later in the week. We are improving these scope languages. We're making them support finer-grained access, so you can say more specific things about exactly what you need and what you don't need. And this is important for promoting privacy and patient choice. We want to make sure people can grant just the access they need to grant. But for starters, and for most deployed systems today, the scopes will look like this. And to dig into a couple more examples of how sort of the scopes look in Smart v1, maybe you're building an app that's going to be able to plot all kinds of observations about a patient. Vital signs, lab results, maybe it'll show social history. So you could ask for a scope like patient/observation.read, as well as patient/patient.read. And what this one means is I want to be able to read the patient demographics, the patient resource pertaining to the patient in context. And when you're asking for 2 scopes together over the wire, you just put a space between them, and that becomes the scope request string that you use in OAuth. A more complex app that might be rendering data from all over a patient's chart might ask for patient star.read. If you're doing an electronic prescribing app, you might ask for something like patient/medication order.write. That would be signaling that you need to create new resources in a system. And then I mentioned user-level scopes. So if you're running an app, for example, that's going to help a clinician manage their schedule for the day, it's not about any one patient. And so you can ask for any permissions that the user has. And in this case, you would be able to see any patient records or any schedule data that the user who's running the app has access to. And that's the basic delegation principle. An app like this is never going to get access to data that the user running the app can't see. So you should think about this as the app gets a subset of the user's permissions, perhaps up to and including all of the user's permissions, but usually much more narrowly scoped. So one way to make this concrete is to take a look at the apps that people are building in the real world. And I should say that most of the EHR vendors that offer support for these APIs today have their own version of a gallery or a store or an app registry of some kind where they surface for their customers, hey, here's all the apps that have integrated with our system. But we also make one available publicly at apps.smarthealthit.org, and that's the Smart App Gallery. Anybody can go and list their apps there. It's designed as a community resource. There's no cost to list your app. There's no license agreement that you need to provide. But it's just a public utility to be able to browse these kinds of apps. And it has a couple neat features that I think are worth pointing out here. One is that it categorizes the app by kind of the target audience or the area of care that it's focused on. But you can also drill in based on the version of FHIR that's supported by the app. So if you've got an EHR product that supports FHIR R4, you can just focus on those FHIR R4 apps. You can also zoom in by the EHR that your app is known to work with. So as an app developer, you can come in and say, well, I've tested my app with these 3 EHRs, and then people can browse based on that. But the other kind of neat feature that I think is worth mentioning is this button here that says Try App. And the idea is that app developers can, if they want to, surface a demo inside of this gallery so that in addition to just describing the app and providing screenshots and providing videos and providing this kind of metadata, all of which is very useful, you can also surface a button that lets users test out the app against a sandbox. And I'll talk more about the sandbox in a moment. But just in the context of the app gallery, you could see the sandbox as some place where a user could log in, could pick a patient, and then the app gets to run against that patient record. So in this case, I'm seeing an app that's going to calculate cardiovascular risk based on the demographics of the patient that are in context here. So that's just an example of how the gallery can surface that sort of functionality in line. And we find that, in general, the more that we can make the app capabilities visible to end users, the easier it becomes for people to choose the right apps that might solve some of their problems. So I want to talk a little bit now about adjacent capabilities, adjacent specs and features out there in the landscape that are designed to work well with the Smart App launch that might be combined to meet more use cases. So one that comes up very often is, Josh, you've talked a lot about end users delegating their access to an app, running an app that's integrated into their EHR or into their patient portal. But what about like a clinical data service that's just running as a headless service somewhere on a computer, and it just needs to connect and access data and maybe spit a report out of the printer once a week? We've got tons of these kinds of things in healthcare. And we have a spec for that too. So that's called Smart Backend Services. And the idea here is there might be no user in the loop, but the app has been authorized to access certain kinds of data in a B2B, business-to-business kind of fashion. We don't call those apps, we actually call them services. So you'll hear me using the term service to describe that kind of thing rather than app. But we have a specification that's part of the Smart App Launch spec that talks about how to connect those backend services, how to register them, how to authenticate them. I won't go into detail on it here because there's going to be a separate session on smart bulk data that goes into the details of how those backend services work. But for this presentation, suffice it to say there's a spec for that that's built into the Smart App Launch that allows for these backend services to connect. Another really common use case in the clinical world is decision support. How do we make it easy for clinicians to understand at a glance what a given patient's risks are, what the right clinical choices, maybe for diagnostics or for treatment, might be, and how do you help people follow guidelines, follow the right triage protocols and workflows to make the right decisions? And one answer there is, well, you could just do all that in a smart app, right? The app becomes the unit of decision support. A clinician knows that they need decision support, so they run that app. They use it, it's got its own UI, they get what they need from it, and then they go back to the EHR and they make the right diagnostic order, or they make the right treatment order. And that is totally a story, and it's the lightest weight integration story that I know. But we can also go deeper. So one thing that you can do is use the CDS hooks, Clinical Decision Support Hooks specification. And there's a session at DevDays on CDS hooks as well. The focus there is being able to ask for some automated advice during the clinical workflow. So like when a clinician opens a patient's chart, or when a clinician starts prescribing a medication, how do we get information from an external service? And sometimes the information you want is, hey, for this patient, you should really run this triage app. 80% of patients, you probably know the right thing to do, but 20% of patients, there's some extra considerations. It would be really a good point in your workflow to run this app. And CDS hooks provides a way to do that, among other things, to surface a contextual link that is bound to a patient at the right point in the workflow where a clinician could actually benefit from running that app. And then the other part of this loop is if you're running an app that's helping you do decision support. Maybe you're in the process of prescribing a medication, but this app is helping you pick the most appropriate medication for the circumstances. Well, that starts to sound like e-prescribing. So you could say, well, great. Well, the app could just take over the prescribing process and go ahead and complete the prescription. But that is actually a very complicated clinical workflow for a lot of good reasons. You need to do things like allergy checking, drug-drug interaction checking. You need to be integrated pretty deeply with the core EHR e-prescribing capabilities. For some apps, that's the right choice. But for others, we provide a more lightweight option called Smart Web Messaging, where the app can basically return a message to the EHR and say, hey, Josh just decided to update the medication prescription that he's been working on. Here's the updated version. It's not the same as writing a new piece of data to the EHR. It's not the same as like changing a FHIR prescription in a FHIR server somewhere. It's just sending a note to the EHR user experience to say, hey, here's a selection that was made in the app, and then the EHR gets to deal with it downstream. So it's a handoff point that allows for the existing functionality of the EHR to take over when the app wants to hand off that workflow. So that's called Smart Web Messaging. I think that's all that I want to say about web messaging for today. It's the most recent piece of the puzzle in this Smart App Launch kind of suite of functionality, but it's one where we're really looking for implementation feedback, and we have what we call a catalog of events that apps can communicate to the EHR, and we're looking to build out that catalog as a community over time. I mentioned smart bulk data in the context of backend services, but there's one other important aspect of bulk data, which is, what if I want to get access to a whole population level data, a whole population level of data at once? I'm not running on one patient at a time. I'm not just helping a clinician manage their schedule for the day where they're seeing like 10 patients. Those things you can do just fine with single patient APIs. Maybe you've got 10 patients on your schedule. You write 10 FHIR API requests to fetch the data for each. No big deal. But what if I want to calculate care management trends across 10,000 patients or 100,000 patients from a whole practice or health system? At that point, doing single patient API calls really isn't going to work in a performant way. If it's your only option, you might be able to stitch bits and pieces together. You can write a batch job, and it runs overnight and does a few, and then the next day it does a few more. And I mean, we see a lot of this in real life because sometimes it's all you can do. But we wanted to have a first-class solution for those problems as well. And so that's what the FHIR bulk data specifications provide, is a way to export data about an entire population or a subgroup of that population in one sweep. And so Dan Gottlieb is doing a session as well as a Let's Build tutorial on bulk data. If you're interested in learning more, that's the right session for you there. And I also mentioned this challenge earlier when I talked about the regulatory timeframe of EHI export. I won't go into detail here, but the FHIR API is a great way to access core data. For all the rest of the data that might live in an EHR, there's kind of this open question. And in the US, at least, the regulatory framework basically says, every product needs to have some story here, some way to do a full export. It could be using custom formats. It could be using ad hoc decisions about how to lump up all of the rest of the EHI. But there's got to be some way to get the electronic health information out. And even if you use an ad hoc data format, even if you're using a proprietary data model, those models have to be openly and publicly documented, and they can't be like a trade secret. So at least there's some sort of liquidity story for getting data out. We're going to learn a lot more over the course of the next year about how well this worked, how well this will work. I think there's an open question here, and we'll see what kinds of capabilities the vendors are launching on that front. But bear in mind, as an app developer, there could be a very long tail of clinical data in an EHR. Oftentimes, apps need stuff that goes beyond the core data set, and EHI export might be one way to help fill that gap. Probably more costly because you've got to build custom importers, and it's not the place where you'd like to operate. But if you can get 80% of what you need through a core data API, and you can scrape together the other 20% using EHI export, that's still better than trying to build a screen reader that takes pictures of the EHR and does optical character recognition on it. So there's a good set of options on that front. Let me say a little bit about some of the open source community tools that we develop. And these are done largely through the Smart Health IT project at Boston Children's Hospital. There's a documentation website that lives at docs.smarthealthit.org, which provides kind of introductory tutorials and links to some of the common libraries and tools. And this link is also in the slide deck, so you can follow along from there. And alongside that, we provide our own sandbox. This is what was powering the example I showed you earlier in the gallery. The sandbox has a set of clinical data, most of which are synthetic data from the Cynthia project, some of which are de-identified longitudinal patient data, some of which are pulled together from an NHS project on patient-reported outcomes. But we put together this sandbox as a place for developers to be able to quickly try out the API capabilities and integrate with the Smart App launch. I'll show you a very quick demo of what we call the launcher, which is kind of the way that an app developer can start connecting to that sandbox. But we're going to do a Let's Build session where I'll go in much more detail into how the launcher works and show you how you can use this to build and integrate your own apps. But the basic idea here is you tell the launcher what sort of app you're building, which of the different Smart App launch flows you plan to use. So maybe I'm building a patient-facing app that does standalone launch, like the Apple Health Records or Common Health example that I mentioned earlier. So you can tell the app launcher that that's the kind of app you're building. Maybe you want to simulate different error conditions, because in real life, it can be hard to test how your app handles the error message when it has been told that it has an invalid access token. So you can choose the error conditions that you want to test, or if you want to test the happy path, you don't simulate any errors. And then what you get is kind of a virtual FHIR server URL that has all of your configuration choices built into it. So you can tell your app, here's the FHIR endpoint that I want to connect to. And that will behave exactly in the manner of these options that you've selected. And you can do things like pre-selecting a patient. So if you know that you need to test the app against a diabetic patient because it's a diabetes management app, you might find in the patient picker a patient that works well for your use case, somebody who has that problem on their problem list. And you can pre-select that patient. And when you do that, you'll see the app launcher fills in this patient box here. And now the URL for the virtual FHIR server has gotten longer, because what's happening under the hood is that virtual patient ID has been embedded into this kind of FHIR server URL. So this is a little technical trick that allows you to configure a FHIR server to work however you need it to for testing your own app. And that level of flexibility makes it very easy to test all kinds of different circumstances. So once you've configured your FHIR server to work the way you want, you can run a sample app, or you can run your own app. And in the case of this sample app, it's going to go through the standard Smart App launch. I can approve its access. And then the sample app just spits out a bunch of the technical artifacts that it used to get its authorized response. So it gives you the access token, what's called the ID token, which is the single sign-on information about the user who launched your app. And then it just makes, I think, one clinical API request. It fetches things like the patient record so that you can see the FHIR data associated with that user. So if you want to learn more about how to use the launcher, if you want to test this out against your own apps, we're going to have a session later today that's the Smart on FHIR Let's Build session. And if you want to learn more about Smart V2, we're going to do that later in the week. For the Let's Build, we'll be starting with this example here, which is hosted on glitch.com. So even if you don't come to that session, you'll have access to all of the code and the demonstrations from it, and you can try things out on your own time. If you've got questions, the best place to come is the Smart channel on chat.phir.org. There's a good community there, paying attention, a lot of good support for folks who are just getting started in this space. Last thing I'll mention is software libraries and sandbox environments. So software libraries, we maintain a couple as part of the Smart Health IT project at Boston Children's Hospital, but there's a lot more that are maintained by the community. A couple of these are the focus of DevDays presentations, so if you want to learn more about working with FHIR data in .NET or in TypeScript, those are a couple that I know are represented here at DevDays this week. But whatever your programming environment or programming language of choice might be, there's probably someone else out there in the community who has used that environment or that language to talk to a FHIR server. And then there might even be good off-the-shelf tooling. Everything I showed you in the sandbox includes a set of open source sample apps. So if you want to drill in and see things like that blood pressure app that I mentioned, that was my own timer for myself. We're about the 10-minute mark, so we're going to switch to Q&A in 1 minute. If folks have questions in the room, feel free to come up to the microphones. Otherwise, we can source them on Whova as well. Last thing I wanted to mention was public sandboxes for testing. We've got a couple, like I mentioned, the Smart Health IT Sandbox, and there are other kind of generic community-maintained sandboxes. Graham Grieve has one on the FHIR test server. There's an organization called Logica that maintains a sandbox. And then all of the EHR vendors that support Smart on FHIR have their own sandbox or testing environments. I've listed a few here that I'm familiar with, but really, if you go to the healthit.gov site, which is called CHAPL, the Certified Health Product List, or something very similar to that, you can search for each certified product that supports these APIs. What they don't support is deep links to searches. So that wasn't really the best experience, but you can dive in yourself, and you can choose the certification edition of 2015 Cures Update. That Cures Update is the one that actually requires these APIs. And then the certification criteria that you're interested in is the API certification criteria, or 170.315G10. Just rolls off the tongue. And so if you do that, you'll see there's a list of about 14, exactly 14, products that are currently certified to these API conditions. And the expectation is by the end of this year, this list is going to get much larger as vendors get their production implementations ready to meet those regulatory deadlines. So that's the introduction I wanted to share with you all. Hopefully haven't covered too much ground, but I wanted to orient you to a lot of work that's happening in this space. And let me see if there are questions either from the audience in the room or from the audience virtually. See, we've got one in the room. Thank you.
Great talk, Josh. Titus Schleier from the Reagan Chief Institute. I wanted to drill a little bit more into the UX integration that is so key to Smart on FHIR. I'll start with a funny anecdote. When I wrote my first FHIR app, we knew it was going into Cerner. And so I said to my health system colleagues, can we get the UX design guide from Cerner so we can make ours look the same? The word was, of course, no. And so then we kind of ballparked it. But my question is this. Will there at some point be like skinning by the parent system to the app so I can inherit style sheets and all the designs and don't have to worry about these things?
Yeah, so it's a great question. And actually, this is something we spent a lot of time talking about with the Cerner team in particular in the early years of the SMART project, 2011, 2012, 2013, even a little bit later, I think. And so the use case is very clear, right? You don't want to put people into a disjointed environment where they've got totally different apps that look and feel different UX paradigms. It'd be nice to have consistent style guides, but of course those might vary from EHR to EHR. So as part of the current spec, we have what we call this experimental capability that does a little bit of what you're describing, which is sort of a style sheet-like. And I have to say, this experiment has not been successful in the sense that I don't know anywhere it's being used to good effect in the real world. And this also speaks to some of the hubris of standards development, right? You think, I know how to solve this problem. I'll introduce the right abstraction. I'll give people a way to express what they need. And then they'll go and use that and be very creative with it. But that hasn't been our experience. Maybe it was the wrong abstraction. Very, very possible. But what exists right now, or maybe it was ahead of its time. It's still hard to say. What we have right now is this smart style URL, which is when your app launches, the EHR can tell your app the URL for what we call a smart style JSON object that can set things like foreground colors and background colors and fonts. And this is a little ad hoc, but it was based on things like Cerner's real-world experience doing this sort of skinning with their customers. And we said, well, better to start with something that we know has been a real-world need rather than trying to abstractly get apps to integrate arbitrary CSS. So that's what we've defined. Would still love feedback and implementation experience on it, but from my perspective, it has not been one of the more successful extension points that we've introduced. Other questions, thoughts, comments? Yep, one in the audience here and one online. We'll do online and then back to the room?
Yeah, let's do the online question first. So it's a question from Janice. Is the synthetic data in the sandbox UK oriented? You mentioned getting some data from the NHS.
The question was, is it
UK oriented?
The patient-reported outcome data came from a UK project. This was in the early days where we were launching the sandbox, and we're working with ONC around objectives for patient-reported outcomes. We didn't have a data set of patient-reported outcomes in the US to use as samples, but there was something that was sort of a close enough fit available as an open data set from the UK. So that was the origin of those data, and that's sort of why we used an NHS data set on that front. Mostly the idea was just to surface for developers something that had the right shape, rather than for it to be like deeply realistic and accurate clinical data. Even having access to data with the right shape is very helpful for testing and demonstration, but it's always better to go deeper on that front. Another question in the room, please?
Hey, I'm Dan from the Innovator team, and a longtime fan of the Smart on FHIR project. I was curious too if you would ever consider enforcing certain browser types or browser versions to be compliant with Smart on FHIR as a specification.
So the question is whether we would consider requiring certain browser versions or features. I mean, there's a sense in which we implicitly have some requirements in order to be able to do things like CORS requests or in order to do things like web messaging. But for example, from a security analysis perspective, that's a very difficult thing to do at the level of a spec like this. Things change quickly. And then the other really challenging area has been for clinician-facing apps, EHR integration is key, but the EHR vendors often manage their inline browser environments in ways that have a long legacy component to them. We, as a standards project, don't really have a lot of control over that. We see things evolving, sometimes slower than we would like, usually much slower than we would like, but it's not a place where we really have a lot of control to exert. So what we describe are the capabilities, and then any browser that can meet those capabilities is kind of fair game. I'd love to touch base offline about what you see as the opportunities there, because it may be there's more we can do, even in the realm of what we sometimes call best practice guidance, right? Even when we don't say, thou shalt, we can still say, this would be a really good idea, and those kind of statements can help too. Do we have a few more minutes?
Yep, we have 2 more minutes.
Great.
So if
one
anyone has
online
some...
and then one in the room. We'll go quick. Yeah, let's do online
no,
first.
we don't have any online
Okay,
questions.
in the room. Awesome.
Have you seen a lot of support in the EHRs for writing back reports to the EHR?
The question is the ability to write back reports?
Yeah, for a clinician-facing app, which is writing back to the EHR.
So in terms of write back, we don't say anything special about writing in the smart specs today. It's a capability you can ask for, just like any other. And the theory is if you're granted that permission, then you can make those FHIR API calls. So at the level of smart, we're sort of agnostic to that. But practically, to answer your question, the vendor capabilities vary. Some of them, for sure, do include the ability for authorized apps to write back both structured and unstructured data in a certain context. But oftentimes, that becomes a decision of a healthcare provider organization. Like they want to use a certain app, the EHR supports them, allowing the app to write back certain data, and in that context, the connection works. One of the most challenging things that we've taken on, particularly with this group called the Argonaut Project, a collection of vendors and other participants that have been sort of focused on expanding these specs in a practical way, has been patient write back. So how do we allow patient-facing apps to be able to write back data into the EHR, including things like my at-home blood pressure measurements, potentially including things like lab results that I got from an outside lab that my doctor doesn't know about yet. Those kinds of connections have been more challenging to negotiate, in part because clinical providers on the receiving side need to want that information before it's kind of okay to share. I'll mention very briefly, we do have a project that's focused on patient-facing apps writing back their own state to use the EHR as a small-scale data store. And that includes use cases like end-to-end encryption. So for example, Apple Health has something like this integrated with several EHRs to be able to surface a view with at-home data. So that's maybe the first place that we're focused on write-backs.
And for clinician-facing apps, do you have an example in the Smart App Gallery that you can look into?
I don't know if there's examples in the gallery, but like if you, for example, look in the, I'm thinking of the Epic FHIR APIs as a sort of an easy one to browse. They have a list on the top line of their site, if it will load, describing which data types you can read versus write. And so these have been sort of flagged with create. So this would be a good place to start in terms of writing back document reference data, which would be like those free text reports.
All right. Cool. Unfortunately, we are out of time. So thank you so much, Josh.
Absolutely. Thanks so much.
And also, please make sure to be here for the Let's Build session because they are not being recorded. So it's only for in-person attendees.